let's take a look at cube roots now, or odd roots. They also have some little nuances. Actually, they're a little bit easier to work with than square roots because of what you're going to see what happens. But let's take a closer look at some function values, look at their evaluations, and continue to work through them. So to begin our journey about a cube root, let's take a look at what happens to negative 3 to the third and positive 3 to the third. In both cases, right, negative 3 times negative 3 times negative 3, here we would get negative 3 times 9, so we get negative 27. So this is negative 27. And of course, 3 to the third, same aspect, but we're multiplying 3 positives, we get positive 27. So both of these create different values. Negative 3 cubed creates a negative 27, and positive 3 cubed creates a positive 27. So when it comes to finding their cube roots, we know exactly where they're going, right? What number can we cube and get 27? Well, that is distinctly and uniquely the number 3. What number can we raise to the third power and get negative 27? Well, that's uniquely and is distinctly, and it can only be negative 3. So cubed roots, unlike square roots, don't have the same issues with positive or negatives. So that makes them a lot easier to work with. Their domains, when we talk functionally, are very strong. You can put positives or negatives in them, and we don't have to worry about things having two different cube roots. You have one distinct, one very special number that does exactly what it's supposed to do. So that's the good news. We just have to get used to working with them. All odd roots are the same. I think we saw this. If we took the fifth root of 32, then the answer would be 2. Right? Reason being is because 2 to the fifth is 32. If I took the fifth root of negative 32, the answer would be negative 2, because negative 2 to the fifth power would be negative 32. So it doesn't have the same problems as square roots, where we have to worry about a positive and a negative possibility. If you take the odd root of a positive, you get a positive. If you take an odd root of a negative, you get a negative. So you get one nice distinct value. So let's practice a little bit and talk about simplification. So if I'm looking for the cube root of 64, right, I'm thinking that 4, right? The reason being is because 4 to the third is 64, right? So again, just as a check, 4 times 4, that's 16 times 4. And of course, 16 times 4 is 64. So that is a nice 4. What about the cube root of negative 64? Well, that has to be negative 4, because negative 4 times negative 4 times negative 4, right? That would give us a 16, and then a positive times a negative is a negative, and so we get negative 64. So cube root of negative 64 is negative 4. Here, the negative is outside, so again, we're going to treat this as a multiplication. So we have to figure out what is the cube root of 8 first, and then take its opposite. So the cube root of 8, what number can you raise to the third power and get 8? Well, that would be 2. And then I'm being asked to apply a negative to it. So the value of that would be negative 2. Trying to get a little harder on you guys. You know, if I had a negative of the fifth root of negative 32, well, again, think of this as the multiplication that it is. So before I apply that opposite, I have to figure out, well, what is the fifth root of negative 32? Well, we've already worked that out. That's negative 2. Now we're being asked to take its opposite. So what is the opposite of negative 2? That would be a positive 2. So we're calculating a radical with other things going on, in this case taking an opposite. Looking at the seventh root of the cubed root, the seventh root of negative 3 to the seventh, again, fight the urge to multiply that all out. This 7 and this 7 basically undo each other, right? That's the idea of a radical. And so we're going to get a negative 3 out of that. If I multiplied negative 3 to itself, I'd get a negative number. It'd be a very big one. And then if I took the seventh root of that big negative number, it would be a negative. We'd go all the way back to 3. And so simplifying these is a lot easier. As a matter of fact, when I have the cube root of x to the cubed, right, we don't even need absolute values. It's just x. Because again, if we have negative 2 to the third power and we're cubing it, that's basically the cube root of negative 8, which is negative 2. So it's what I originally had. Power matches the index. We're just left with that base, if you would. If I had the cube root of 2 to the third, right, that's technically the cube root of 8, which is 2. So again, the power matches the index. We're just left with the 2. So that's really nice, right? If n is odd, the n's actually undo each other. They reverse each other, and we're just left with a. So this is when n is odd. So much, much easier to work with than its square root counterpart, where we had to worry about where the negative is at and all that other good stuff. So in terms of simplification, here we're taking the cube root of 27x cubed. This is a product. You can think of this as 3x to the third power. So we're taking a power of a product. This power and this index match each other, so they're essentially undoing each other. And so what's left is 3x. Or you literally can think of this as the cube root of 27 being 3, and the cube root of x cubed just being x. Again, no absolute value needed, because negatives and positives, right, they get their own distinct, unique value, and we don't have to worry about anything. The next one, we're cubing a sum. So it doesn't break down, but this whole thing is the base of that 3. So this 3 and that 3 essentially wipe each other clean, right? So we're left with x plus 1. All right. If you just want to write it as x plus 1, you can. Again, no absolute values needed because of what we saw up here. It doesn't really matter what happens. It handles if we're positive, we get positive. If we're negative, we get negative. Here we have the fifth root of negative 32x to the fifth. Technically speaking, we're looking at negative 2x being raised to the fifth power. All right. And so the power and the index match each other, so they kind of cancel each other out, and what's left is negative 2x. So just like I mentioned here, the nth root of a to the n is just a if n is an odd number. So very, very nice to work with, very, very easy to work with, very strong function because it handles everything. All right, so as a matter of fact, let's go to that function notation in the next video.